the key point. It makes it possible to not believe in God. Without science, everything's a miracle. When you have science, the possibility that nothing is a miracle arises. In any case, so the title, this is the only picture I could get on your webpage of the college. So it's in there somewhere, I guess. I come here not to bury religion or to praise it. I want to talk about some of the issues that are happening nowadays and the potential conflicts between science and religion, and talk about how they're abused on either side. I want to talk about science a little bit first, and then I'm also, since it's origins, I'm going to actually do something of content. I want to talk a little bit of science, as well as all this stuff about science and religion. And then hopefully leave room for some discussion. Hopefully I'll provoke and offend. The context of the current debate about science and religion takes place in the context of current American culture, where science does not play a significant role. And the cultural context of this was really brought home with me. I was just recently in England, and I got a 10-pound note. On the back of the 10-pound note is a picture of Charles Darwin. Okay? On the back of the dollar bill is a pyramid with an eye on it. And gives you some sense of the cultural challenges we face in this country. Those are manifest in lots of studies of scientific illiteracy. And every year the National Science Foundation does a study of scientific understanding, basically, and attitudes towards science. I want to quote the 2001 study because it's my favorite. Here's some depressing statistics. At that time, 53% of American adults were unaware that the last dinosaur died before the first human arose. One of them is running for vice president. 50%, this is the second one's always my favorite. 50% of American adults knew that the Earth orbits the sun and takes a year to do it. That so astounded me when I first saw that I thought it must be a trick question. So I went to the survey. And the survey question was, the Earth orbits the sun and takes a year to do it, true or false? And every year, 50% of people get it wrong. It was a banner year, however. It was the first year in the history of the survey when more than 50% of American adults claimed to know that human beings as we know them today developed from earlier species of animals. First time that more than 50% were in agreement with that statement. It didn't last long if you look at lots of other. Here's another survey in 2007. 60% of American adults surveyed stated their belief that God created humans in their present form less than 10,000 years ago, in spite of the fact that that's just not true. Just nonsense. Nothing to do with God. Humans have been in their present form for a lot longer than 10,000 years. Okay? So that's a little bit of the context of the fact that there's overwhelming scientific illiteracy has contributed tremendously to the misunderstanding of science and to the misunderstanding of what the relationship between science and religion might be, if there is any. I also want to describe the fact that science, there's as you'll see, a great concern that science is immoral. And science has an ethos, which I think is very important, and Richard Feynman described it well. He said, the only way to have real success in science is to describe the evidence very carefully without regard to the way you feel it should be. If you have a theory, you must try and explain what's good about it and what's bad about it equally. In science, you learn a sort of standard integrity and honesty, whether you want to or not. And in fact, though the ethos of science involves a lot of things that I'm quite in favor of. Honesty. Creativity is a key aspect of science, of the ethos of science, or should be. Full disclosure. As Feynman said, you're not allowed to pick and choose. If there's data that disagrees with your theory, you have to include it. And anti-authoritarianism, which is my favorite. There are no scientific authorities. No such thing. There's scientific experts, but there's no one who's an authority in the sense that their word cannot be doubted or questioned by the lowliest, you pick the lowliest graduate student, lowliest dean, whatever. All things are subject to question, and that's a key aspect of science. Now, these are I would argue, in fact, if any of these existed in Washington, it would be a better place. Now, I want to talk about some of the current collision between religion and science around the world, and in this country in particular. But in 2001, here's an example of a collision that occurred outside the country in Afghanistan. This was before the Taliban were our declared enemies. This is a very famous and unfortunate occurrence. The young people may not fully remember it. But these were some wonderful statues of Buddha, probably treasures of antiquity, among the oldest large statues in existence, 1,800 years old. But the Taliban had decided that then their interpretation of the Quran, that you're not allowed to have any likenesses of human faces. So every statue in this country was to be destroyed, beginning with these. There was, of course, a worldwide outcry because these were treasures for all of humanity, but nevertheless they were destroyed. That was a collision between certainly the science of archaeology at the very least and religion. At the same time in this country, there was a collision of sorts. Then House Majority Leader Tom DeLay, who by the way had a degree in biology, which amazed me, argued that in the congressional record that the Columbine school shootings occurred in part, quote unquote, because our school systems teach our children that they're nothing but glorified apes who have evolutionized out of some primordial mud. So evolution was responsible for this Columbine school shootings. Now, so there's a political, as you can see, there's certainly in that case a political problem here. And it's turned into a problem in overall in our society. Now, I want to give another example. This is faith-based science, which is a contradiction in terms. It's nothing to do with religion so much, or maybe it does, but this gives you an example of the other kind of nonsense that permeates popular discourse, particularly politics. Some people have a moral view that abstinence is the correct way to bring up children, and therefore that's what we should teach them. Now, the Center for Disease Control had a Programs that Work webpage, and they talked about 5 programs that were found effective in scientific studies in sex education. This was on the webpage. This is, by the way, since 1996, the government has supported abstinence-only sex education programs, and they'd been studied. And as I say, the CDC, the Center for Disease Control, had up on their webpage the programs that were working, and none of them were abstinence-only. Okay, well, that's fine. That became an official government policy, however, in 2002, that abstinence-only was the government policy. And in fact, not only did that Programs that Work initiative ended, studying what actually worked, but all information on sex ed programs was removed from the website. Okay. So a criminal act, in my opinion. Disgusting. And at the same time, of course, Ari Fleischer said that abstinence is more than sound science. I don't know what that means. It has a proven track record. And of course, there was no proven track record at that time. But in April 2007, a 10-year study following the government initiation of these programs, support of these programs, have been done involving 2,000 children to look at the effectiveness of abstinence-only sex education. There are a lot of conclusions, and I just want to present one which is kind of, at the end of it, you think, is it worth doing the study? Because the conclusion is what you think you should know, anyone would know anyway. The most effective programs are those that say abstinence is the best choice, but birth control and protection are also worth knowing about. I mean, I don't know if you have to be a rocket scientist to figure that out, but indeed it discovered that, in fact, that's the way. Okay, so that should have settled the matter, right? But it didn't. And in fact, this is one showing how nonpartisan I can be. This is the Democratic Congress. In 2007, agreed to increase money for abstinence-only sex education by $28 million. We spent $200 million a year on abstinence-only sex education, at a time, of course, when we talk about government waste. John McCain was more worried about waste on a planetarium in Chicago that teaches children about the universe, but not $200 million that we waste on a program that doesn't work. In spite of the fact that the U.S. has the highest teenage pregnancy rate in the developed world, the highest abortion rate, and the fact that sexually transmitted diseases are on the rise. I point this out just because to demonstrate the problem here with the sort of reason in politics, and in some sense religiously motivated politics, because as I say, I think this is criminal. This is our children, the health and welfare of our children that we're talking about, and some people would rather act based on some a priori moral belief than what actually can help them. And I think and as I say, I think it's very sad. Now, we look to our highest politicians to define public policy, and here's a statement from George W. Bush talking about evolution and intelligent design. He said, both sides ought to be properly taught so people can understand what the debate is all about. Now, this is not an intrinsically stupid statement, surprisingly. It is a perfectly reasonable statement. It's a statement that would make sense if there was a debate. What it represents is not stupidity, but ignorance. Ignorance not in a pejorative sense. The fact is that the president was ignorant of the fact that there was a debate, and he's not alone. Most Americans believe there's a huge debate on this issue. And so I want to talk about that a little bit. First, I want to, however, make a disclaimer, or not a disclaimer, I want to make a statement of fact, that evolution is a fact. There's no discussion, there's no debate, there's no nothing. It's one of the most successful and impressive scientific theories of all time. We physicists have done a con job. We've convinced everyone that Einstein was the greatest scientist, or Newton, or something like that. But in fact, I'm pretty convinced when you look at the person who single-handedly changed our thinking about the world the greatest, I think it was Darwin. And the biologists just aren't as good at self-promotion, I guess. It's been based on over a century of observation, prediction, testing, all the hallmarks of good science. Okay, so let's lay that issue to rest. But nevertheless, there's this huge public debate about this notion called intelligent design. And so the question is, what is intelligent design? Well, it's everything from the notion that life was designed, which is a rather vague statement and interesting to discuss from a philosophical perspective, perhaps. But some people try and make it sound more scientific by saying something like, the notion that existing cellular structures are too complex to have been explained without design. Now that sounds scientific. To something else. Now the reason is there's no really good definition of intelligent design is that, unlike evolution, the notion has not been subject to anything like peer review, and that tends to refine ideas. It's a very vague notion. Now, however, there is a way to define it in the current context. Intelligent design is very simply opposed to evolution. Whatever you think, if you're opposed to evolution, that comes under the rubric of intelligent design. But the question is, why do you have to be opposed to evolution? What's the point? Why are so many people opposed to evolution? And then we come to an issue which, in some sense, does relate to science and religion, as you'll see. It comes from a fear of science. A fear that science is fundamentally immoral because it does not explicitly include God in it. And because God is not an explicit part of science, science not only is fundamentally immoral, but therefore must be wrong. And it has to be changed because it's a danger, and also because God must be an integral part of the world, and therefore science, as we normally carry it out, must be changed. Now, an example of this comes from a group that's now called the Discovery Institute. Sounds much more non-emotional. But it used to be called the Center for the Renewal of Science and Culture. That was much more emotionally charged. And they put out a strategy in 1998. And here's what this supposed scientific think tank said at the time. The proposition that human beings are created in the image of God is one of the bedrock principles on which Western civilization was built. This cardinal idea came under wholesale attack, drawing on the discoveries of modern science. Science attacking religion. And we seek nothing less than the overthrow of materialism, aka science, and its cultural legacies. Science has evil cultural legacies. And they had a plan, strategy, to defeat scientific materialism and its destructive moral, cultural, and political legacies. So the legacies of science are destructive. And to replace those by a theistic understanding that nature and human beings are created by God. 5-year goals, well, the key one was to begin attacking science teaching in the public schools in 5 years. What happened in my home state of Ohio 5 years later, the Discovery Institute came in when there was an effort to revise the science curriculum in the state and started promoting intelligent design, and that's when I got involved in the state the debate and issue. Now, the Discovery Institute has been the major media, public relations promoter, lobbyist of this idea, and they've done an incredibly effective job of winning the hearts and minds of people in the country. By the way, they're in the high end. This is another example of fear. Okay, this is an example of why science is bad. In this case, evolution, which of course is based on Satan. And evolution is responsible for all the evil things in society: divorce, euthanasia, homosexuality, pornography, abortion, racism, and of course humanism, an equally evil thing. And it is the purpose of it, the very purpose of evolution, is to destroy Christianity. Okay, so there's that fear that science is evil. Now this, by the way, isn't just bad science. This miserable theology, of course. It's a disservice to all people of faith to imply that it's better for our children to remain ignorant of the world than to risk the possibility that by knowing about it you may lose your faith. This should be familiar to you. This is what people claim they're fighting in the Taliban in Afghanistan. Right? That's a clear example in madrasas where children are taught nothing, are taught how not to think. And specifically because if they think, there's a fear that it might threaten their belief in Islam. But this is exactly the same notion here. There's nothing different about this approach. Keep children ignorant. Now, the marketing strategy has been very effective. It's the marketing strategy for intelligent design is based on some notions that really resonate with the American public. Open-mindedness. Listen, we should be open-minded about all of the issues, and we shouldn't be dogmatic about things like evolution. Honesty. Let's be honest about the fact that most people don't believe in evolution. And the one that really resonates is fairness. It's only fair if most Americans don't believe in this that we introduce in the schools the alternative. And that latter one particularly resonates with the public, but they all do. The problem is it's really garbage. All three of these are just invented. Because in fact what the public really should see is that this is closed-minded, dishonest, and unfair. It's closed-minded for the reasons I've already shown you. The Discovery Institute now claims that they're a scientific organization whose sole purpose is to do good science, and evolution is not good science. And they like to explore the scientific alternatives. What you saw, of course, the statement at the beginning was that science, it didn't say we're gonna do some experiments to see if evolution is wrong or science is wrong. No, science without God is immoral. We've made that decision, and therefore evolution, which is science without God, must be wrong. That's what we call closed-mindedness. Open-mindedness is when you force your beliefs to conform with the evidence of reality rather than the other way around. Okay? So the whole purpose in that effort is closed-minded, but it's also dishonest. Let's talk about this famous controversy that they're talking about. Where's the controversy? Well, a few years ago, I had a colleague of mine do a survey over 10 million articles in 20 major science journals during a little over a decade, and look for keywords evolution. Okay. Hit that keyword evolution and got about 115,000 articles. Didn't do an exhaustive study, but most refer to biological evolution. Intelligent design, hit the keywords. Well, it appeared in 88 articles, but all but 11 of those were in engineering journals, but it's supposed to be intelligent design. Of the remaining 11, 8 of the articles were in fact critical of intelligent design, and the remaining 3 were actually in conference proceedings. So in the scientific literature, there's nothing there. There's nothing. Now, the argument is made, especially when I talk to debate people in the Discovery Institute, that of course there's nothing in the scientific literature because scientists are censoring out this information. They have a prejudice and they won't let articles on intelligent design get published. Now I've had one of my responses, I've issued a challenge which has yet to be met. I said to them, if any of you can prove that you've been rejected from scientific journals more frequently than I have, I will grant you this. Okay? No one's been able to prove that. Okay? But they also say, well, look, we've given up, so we write books. Look, Darwin wrote a book, so we can write books. Well, Darwin wrote a book. He also submitted articles to the Royal Society, but said, let's look at books. Forget the peer-reviewed literature. So I did the next thing. I went to Amazon.com, and I hit keyword evolution. I got that particular day, I got 21,822 books and articles appearing with the keyword evolution. And again, I didn't do an exhaustive study, but most of them refer to biological evolution as I scanned through it. I hit the keywords intelligent design, 635 hits. Now, about half of those were engineering, so get rid of half of them. And so only half of them are about ID in a scientific or religious sense. Half of the remaining ones were critical of ID, therefore about 150 books and articles that were promoting the notion of intelligent design. Okay. Just for fun, I hit the keywords alien abduction. Got 165 books. So you see, if there's a raging controversy that we should be teaching about in the schools, it's alien abduction. Much as intelligent design in any case. So it's just invented. There's no such thing, there's no controversy. There's a public controversy about an issue that doesn't exist. But the worst part is the fairness issue, because here's how science is done. Often. Not always, but often. The good thing is to start out with a novel claim. It's not required, but it helps. And then we do. Well, then you do research. What's research? You do the thing that Feynman said. You try and prove this idea right, and then you try and prove it wrong. Okay? And then, if you're convinced the idea has merit, then you submit it to a journal. What happens? It gets sent out for peer review. What's that? Well, that means it gets sent to idiots. And they come back and they explain to you, without having read the piece really, what they think is wrong and why they weren't referenced. And then you write back to them using small words. And then maybe, if you're lucky, the thing is published. But big deal, lots of garbage gets published in every issue of Physical Journal, Physical Letters, or any major journal. There's lots of garbage. Doesn't matter, okay? Because what happens is, if it's really interesting, other scientists start to read about it and do research based on it, and then maybe eventually scientific consensus builds up. That may take decades. And only then does it make it into the high school textbooks. That's why high school physics texts are 20 years out of date, at least, usually, because it takes a while. But what do the intelligent design advocates want to do? Well, they just want to get rid of all the intermediate steps, okay? Start with the idea and go directly to the high school textbooks. And that's just not fair. If you want to do science, or something you think is science, you should play in the same playing field. And you don't change science beginning in high school textbooks. That's not where science gets changed. It's changed in the laboratory or in the research bench in one way or another. So the fundamental aspect of fairness is not even there either. Okay, but there are a bunch of arguments that still resonate that I want to review. And one is quite a serious one. Remember that at least 50% of the populace doesn't believe in evolution. In fact, it's worse than that. Let me show you a really, really scary statistic from 2005. So when people were asked, regardless of what you believe personally, which of these do you believe should be taught in public schools? 12% of the American public said evolution only. Almost twice as many Americans said only creationism should be taught in the public schools, and then the rest of Americans said everything. Okay, open-minders. So it's really clear that by far a majority of Americans would like to, at the very least, teach more than evolution or teach no evolution. Okay, so more than 50% of people feel that way. So shouldn't we therefore teach it? Well, I just want to remind you of one of the statistics I presented to you earlier. 50% of American adults know that the Earth orbits the Sun and takes a year to do it. Does that mean, therefore, that we should teach the Earth-centric cosmology in physics classes? Because after all, 50% of Americans think the Sun orbits the Earth. When you present it that way, the answer is obvious. Of course not. Because what people are forgetting here is that the purpose of education is not to validate ignorance, but to overcome it. And if 50% of American adults don't know the Earth orbits the Sun, we better do a better job teaching that. If more than 50% of American adults don't believe in evolution, we're doing a bad job teaching. We should do a better job teaching biology, and not a worse job, not diluting it with nonsense. Okay? Then there's another argument that's really permeated a lot. I heard it again the other day. John Bacon, an interesting name for this guy. He was from the Kansas State Board of Education. When they were arguing that evolution should be removed from the curriculum, he said, I can't understand what they're squealing about. Millions or billions of years ago, I wasn't here and neither were they. This is historical science. It's all in the past. We weren't around. It's a story. It's history, like the Bible. And the point is that totally misperceives what science is all about. In fact, because all science is historical science. There's not one bit of science that isn't historical science. And all physics, all chemistry, all biology, all geology, all of it is historical science. What do we mean by that? Historical science means that you base your ideas on the past experiments and observations. But big deal, that's not what science really is, because the key thing about science is you then predict the future. That's what makes it science. If it were just the first part, it would be a story. And probably the biggest misconception about science among the American public is that science is just one story. But it's not a story. It's a story with consequences. You take that story and you make predictions and you compare them with experiments and observations that have yet to be performed. So you predict the results of those experiments and observations, and then you compare them to your theory. And in that sense, evolution is just like Newton's law of gravity. It's exactly the same. It's just as historical. And in fact, to give you a sense of how historical things are, here's from doesn't really matter if you can see it that well. This is the sun, in case you didn't notice. And so, well, the sun is not a historical object when we look at it. Well, you can say, okay, it takes 8 minutes for the light to get from the sun to the earth, but that's not really history. But it's not quite that way. So does anyone know how long it takes? So the sun is powered by nuclear reactions, we discovered. So the light that comes out of the surface of the sun originated in the center of the sun with nuclear reactions. Do you know how long it takes for the light to get from the center of the sun to the outside of the sun? Okay, about 1 million years. Takes the light. So every bit of light that's emitted from the surface of the sun originated in a nuclear reaction 1 million years earlier. Okay? So we really are doing historical science when we look at the sun. We're looking at the energy that was emitted 1 million years earlier. And by the way, if the solar system and the Earth were 10,000 years old, the light wouldn't have made it out to the surface. Okay? So we already know. Every week I like to think of another thing that refutes the 10,000-year-old idiots. And so anyway, when we do astronomy, when we look at the sun, we're doing historical science. Because we then make predictions based on that million-year-old data. And we make predictions of what the interior of the sun is like. And we can make predictions about the temperature profile and the density profile. And we can test those predictions. And they're bang on right. And it's the same with evolution. We can make predictions based on what we have observed from either fossils or the genetic relationship between mammals. And we can make predictions of a whole bunch of things which we can go out and test. And for over 100 years, evolution has satisfied all of those tests. Now we get to a little more dicey question. Evidence of design. This is where you get a little more subjective. Is there evidence for design and purpose in the universe? Well, design is a tricky subject because it's really in the eye of the beholder. Okay? I mean, clearly, if you see, say, Christmas ornaments, you look at them and you say, of course, they're clearly designed, right? But of course, these aren't Christmas ornaments. These are ice crystals that have been dyed so you can see them. But these are just crystals of water that have formed these beautiful patterns, snowflake patterns. And we know they're not designed. We know that you take a polar molecule and you allow it to have phase transition in the right way and you form beautiful patterns. So the laws of physics and chemistry produce these things. It's not as if we have to design every single snowflake. Okay, well but what about, it's obvious that some things are designed. Human structure is designed. Take Buckminster Fuller. He'd make these beautiful human designs, a geodesic dome. Clearly there's intelligence involved. Well, that is unless you take soot, and you find Buckminster Fullerene, carbon-60, which is also a nice geodesic dome, which of course is in soot. You can't think of anything a little less designed than soot. Okay? So design is really a subjective notion. Things can look like they're designed, but that doesn't imply they're designed. Of course, it doesn't imply they're not designed either, which I'll get to. It just means you can't make that inference by just subjectively staring at things like that. Now, let's talk about intelligent design a little bit. And I won't spend a lot of time on the biology of this, but I just want to point out that this notion that there's intelligent design is at least questionable if you start thinking about nature. And in particular, think about species. First of all, almost all species that have ever appeared are now extinct. Over 99.5% of all species that have ever roamed the earth are now extinct. So you've got to ask, design? Good design? I would spend, if I was talking about biology, I think I'd talk a little bit more about that because I talk about bacterial flagellum, but I'm not going to. I want to just point out that every scientific claim, every single one that's been made from the genetic relationships between humans and chimpanzees to the non-existence of transitional fossils to the evolution of bacterial flagellum to the nature of blood clotting, every supposed challenge to evolutionary biology has in fact been proved wrong. I think I'll show you one because it's one of my favorites. Yeah, I have it. This is the lack of existence of transitional fossils, particularly between ape-like creatures and human creatures. So the interesting thing about this is just the creationist literature. All of these are creationist documents, and here are fossils that have been analyzed by these creationists. And you see everyone agrees that this one's ape-like and this one's human-like. But even among the creationists, you can see that it's a perfect example of transitional fossils. In the creationist literature, you get some fossils are more ape-like, but they can't agree. And then they get more human-like, and so the point is that there's clearly a transition between things that look completely ape-like and completely human-like. So even if you take that literature alone, the argument that there aren't transitional fossils is falsified because, of course, here's an example of it, just in this one case. Now, the thing I want to get at is a really important point, probably the most important point I'm going to say in this discussion about science and religion, is that the science, I've argued there's no evidence for design in humans or in biology. But the key point is that the science is independent of questions of design and purpose. It just doesn't matter. And the best example I know of that comes from cosmology. In fact, in the piece I wrote in the New York Times that caused such ire in that cardinal, who of course had to recant after I wrote the Pope, was really a statement about the fact that there could be a coexistence between science and religion. In particular, the example I used was Georges Lemaitre. Georges Lemaitre was a Belgian priest, but he was also a cosmologist. He was the first person to show mathematically that Einstein's theory of general relativity required a Big Bang. It was inconsistent with a static universe. Okay? And Einstein didn't buy this, by the way. Einstein didn't like the idea and derided it for a while, because Einstein wasn't really open-minded initially, or forever. But eventually, he was a scientist, so he realized that Lemaitre was right. But when Lemaitre made that realization, what happened? Pope Pius got so excited that he wrote a public letter saying, science has proved Genesis. Okay? Now, what did Lemaitre do when that happened? Lemaitre's a priest, Catholic priest. He wrote the Pope, and he said, stop saying that. This is a scientific theory. You can test it. It makes predictions. It makes scientific predictions. Now, if you have a certain religious belief, you can take it to validate that religious belief. On the other hand, if you don't, you can take it to equally well validate the notion that there's no need for God, that you take the laws of physics back to t equals 0, and everything just works. What you take out of the theory depends upon your religious or philosophical background. But the theory works or doesn't work independent of them. It just doesn't matter whether you believe it or not the Big Bang really happened. It doesn't matter whether you believe it or not, evolution is a fact. It's independent. And you should realize that fact, and therefore, first of all, not try and use it one way or another, but also not feel particularly threatened by it. Namely, if you cannot believe in God if evolution happened, then you better give up your belief in God. But if your belief in God for whatever reason is deep enough, then since it happened, the existence of evolution cannot be inconsistent with the existence of God if you believe both of them are there. And so you have to bring the two together in some way. But the science is just independent of that. Now I want to, as I say, I got asked, this is origin, so I want to spend a little time on the universe before I get to some of the final issues. I want to talk to you about some of the most amazing observations we've made about the beginning of the universe and how it tells us something which will reflect on the issue of whether the universe is designed, and in fact has caused a lot of debate, some of which probably will come up in the talk next time by my friend and colleague Paul Davies. This is an amazing discovery that's been possible in the last decade due to some new observations in cosmology. Einstein told us, general relativity tells us that mass and energy curve space. Space actually curves in the presence of mass and energy. And the big question is the universe curved on large scales? And it turned out it could exist in one of three different types of universes called open, closed, or flat. And Sounds good. And in a closed universe, the universe is curved enough that it curves back on itself. So if you look far enough in that direction, you'll see the back of your head. Okay? And an open universe, that doesn't happen. And people are quite interested. The reason I got into cosmology as a particle physicist is that it turns out if you have a matter-dominated universe and it's closed, it has to expand and eventually stop and contract. An open universe could go on expanding forever. So I figured if I could figure out the geometry of the universe, then I'd be the first person to know how the universe would end. That seemed like a good idea. So, but now it turns out we've been able to measure the geometry of the universe directly, and I want to show you this. It's one of the great triumphs of the human intellect and experiment. But to think about how we can do that, I want to ask you the following question. How would you measure the curvature of the Earth if you had no recourse to outside space, so you couldn't go around and see the Earth was curved, or you couldn't go around the Earth? Okay, well, here's how you do it. You take a triangle, and then you ask a European high school student, what are the sum of the angles in a triangle? And they'll tell you it's 180 degrees. And you say, okay, but that's because you learned your geometry from Euclid. On a curved surface, you can do something else. Here's the Earth. I can draw a triangle that's quite different on the surface of the Earth. I draw a triangle. I take a line along the equator. I make a right angle, go to the North Pole, make another right angle, come back to the equator. And now I have a triangle with 3 right angles adding up to 270 degrees. And therefore, if you make a big enough triangle on the surface of the Earth, you'll see it's different than 180 degrees, and you can measure the fact that the Earth is curved. Now, it turns out, remarkably, that exactly the same thing is true for a curved 3-dimensional space, which is harder to draw. A big enough triangle would tell us if the universe is curved on large scales. And in fact, the originators of this thing called non-Euclidean geometry, actually, some of them actually tried to look at big triangles and measure them and see if they deviated from 180 degrees to learn if we lived in a curved space. The trouble is they didn't have a big enough triangle, but we have one now. Due to one of the most important observations in cosmology, the cosmic microwave background radiation, the afterglow of the Big Bang. One of the many reasons we know the Big Bang really happened. It was discovered by accident in New Jersey, of all places, by 2 people who didn't have the slightest idea what they were doing. But they won the Nobel Prize anyway. And actually, if you're older than a certain age, you've all actually seen this cosmic microwave background. I won't tell you now. You can ask in the question period. But we can. The reason they won the Nobel Prize is that it gives us a signal of the universe back at almost its earliest moments. And I'll show you the picture of the universe back in its early period. So where does it come from? Well, here's the Earth, and we look out, and these are not sperm; these are galaxies, and if we look out at galaxies 1 billion light years away from us, then we're looking at them as they looked 1 billion years ago. So we're doing cosmic archaeology. We're looking back in time. Now, if the universe is 14 billion years old, which it is, you would expect if you look back 14 billion light years or so, you would see the Big Bang. And in fact, you could, in principle. But you can't in practice. Why? Because between us and the Big Bang, or the observation of the Big Bang, is a wall. A wall just like this one. It's not solid like this, but it's essentially the same. I can't see that past that wall. I can't see outside because the wall is opaque. Now let's think of what happens in the universe. We're looking back in time. The universe has been expanding and cooling. So the universe was hotter and hotter and hotter. If we go back to the time when the universe was 100,000 degrees, the temperature of the universe was 3,000 degrees above absolute zero. At that temperature, hydrogen, which is the dominant stuff in the universe, gets broken apart. Hydrogen is made of protons with electrons going around it. But at that temperature, the radiation is hot enough to break apart hydrogen. Every time an electron gets bound to a proton, it gets broken away again. That means the matter is not neutral. It's separated. It's charged. It's what we call a plasma. And a plasma is opaque to radiation. You can't see through it. So you try and look past this. You can't. The universe is opaque. Now let's let the film go forward. Opaque, 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 opaque. Then, boom, the universe cools down 3,000 degrees. Suddenly, protons can capture electrons, form neutral hydrogen. Neutral hydrogen is transparent to radiation. And then again, it's just like this wall. I can see this wall because light from those lights gets absorbed on the surface, the atoms on the surface of the wall gets re-emitted. The air is transparent, so I can see all the way to the wall. The same thing for our universe. If we look out, we will expect to see radiation coming at us from all directions from that so-called last scattering surface. And since the radiation is cooled as the universe is cooled, it's no longer 3,000 degrees, it's now 3 degrees above absolute zero, and that's what they discovered by accident in New Jersey. Now that we're immersed in a bath of radiation at that temperature. But the neat thing, of course, is that radiation gives us a picture, literally a picture of what the universe looked like at that time. Now, in that picture, there's one scale that's important. It's 1 degree, this scale here, 1 degree. Why 1 degree? Well, this line here represents a distance of 100,000 light years across. It's a ruler, 100,000 light years across. Now, Einstein told us that no information can travel faster than the speed of light. So that means if you're over here at this time, you can't impact on anything that happens over here, because light can't make it from one place to the other. Or let's say you're a lump of matter. If you're a lump of matter that's this big, well, you collapse due to gravity, and then you heat up, and all sorts of microphysics happens. But if you're a lump that's this big, you don't even know to collapse. It's like Wile E. Coyote when he runs off the cliff, okay? You don't even know to collapse because gravity travels at the speed of light as well, and you don't even know you're a lump because your size is bigger than gravity can probe at that time. So the largest lumps that can really significantly collapse are this big. That gives us a ruler. Because at distance at the cosmic microwave background surface, you have a ruler that's 100,000 light years across. Now, in a flat universe, light travels in straight lines on average. And you can ask what angle would be subtended by that 100,000 light year across ruler. It's 1 degree. But in an open universe, because light rays diverge as you go back in time, the angle spanned on your eye is smaller. The ruler looks smaller. Okay? Maybe half a degree. In a closed universe where light rays converge as you go back in time, the angle spanned by the ruler will be bigger. It might look like it's 2 degrees. So all you have to do is take a picture of that cosmic microwave background surface, look for the lumps in it, and ask, are they half a degree on average, or 1 degree, or 2 degrees? And that's been possible in the last decade. This was one of the first experiments that could probe it. It's one of my favorite experiments. It's called the boomerang experiment in Antarctica, and I hired the head of it when I was chair at Case. And it's a balloon that takes a microwave receiver way above the Earth's surface, because the Earth is hot on this scale. You want to get away from it. And looked at a small region of the sky trying to measure the microwave background radiation and get an image. Okay? And this balloon went around the world, which is actually easy to do in Antarctica. At the South Pole, it's particularly easy. But here, it took about 2 weeks to go around and come back to where it started, which is why it was called the boomerang experiment. It looked at that region of the sky and captured, well, this is a false color image of what it saw. These are hot spots and cold spots in the microwave background radiation corresponding to lumps in the early universe. And here's the image here. Now, here are 3 universes we've created on computers to say, okay, in a closed universe, how big would 100,000 light year across lumps on average look? And they'd be about this big. Well, these are bigger than this. In an open universe, here's what the lumps would look like, and the average lump size would be about that big. Well, that's smaller than these lumps. But if you take a flat universe, it's just like Goldilocks, just right. And we now know, in fact, by measuring this, that the universe is flat to high accuracy. Okay, which is interesting because us theorists, of course, we don't need observers. We knew the universe was flat. We don't need observers because we know the answer whether we're right or wrong. In this case, it was right because the only mathematically pretty universe is flat, but we are completely wrong about the reasons why it was flat. Well, by the way, for those like quantitative aspects, this is a much better image of the entire sky with what's something called the WMAP satellite. And this is the prediction. Here, most of the lumps, we're just counting lumps basically. Most of them are 1 degree across. That's the data. That's the prediction for a flat universe. So we finally answered the question, is the universe flat? And the answer is yes. But it turns out that it's flat for exactly the wrong reason. And because I'm not giving a physics lecture, I won't go into the details. It turns out the only way you can make everything we see consistent with a flat universe is if most of the energy of the universe resides in empty space, resides in nothing. If you take the energy associated with everything we can see, all the stars and galaxies that we can see, that accounts for about 1% of the total energy of the universe. We are just a little bit of cosmic pollution. We are completely irrelevant in a cosmic sense. Let me say that statement again. We are completely irrelevant. You could get rid of us and everything we see, all the stars, planets, aliens, everything, and the universe would be essentially the same. 30% of the energy of the universe is made up in something called dark matter, which is the dominant stuff of galaxies. It doesn't shine. We actually think it's made of some new type of elementary particle, totally different than what makes up the stuff here on Earth. But what makes that interesting is it's not just out there, it's in this room, going through your bodies as you nod off during this lecture, okay? And that means we can do experiments here on Earth to look for that. And we're doing them. But 70% of the energy of the universe isn't in any of those things. It resides in empty space. And we don't have the slightest idea why it's there. If anyone comes to lecture to you and they tell you they know why it's there, they're lying, especially if they're a string theorist. But the thing that makes it interesting, the reason we care about it, is that its existence is tied to the very nature of space and time and to the origin of our universe. That's why we want to learn about that stuff. But it also has another implication. It will determine our future. The fact that we live in a universe dominated by what's become known as dark energy, a substance that we do not understand, and we don't know its future. But because it dominates the energy of the universe by general relativity, it will determine our future. And if we are correct, measuring it as we have, then we kind of get an idea what the future is. And let me just tell you the future. This was a graduation address given at a private girls' school. I've given 2 commencement addresses, and I've never had the guts to say this, but he began his speech by saying, things are going to get unimaginably worse, and they're never, ever going to get better again. That was before the Bush administration was elected, by the way. But in any case, the point is that, the reason I put it up here is that describes the universe. If dark energy dominates the universe and continues to, we live in the worst of all possible universes for the future of life. You could not pick a worse universe for the future of life. Okay? So if this is the case, forget the fact that 95% or 99.5% of the species on Earth have become extinct. If this is the case, life cannot survive in such a universe. So it is the worst of all possible universes for life, so much for intelligent design of the universe. Okay? If you want a universe whose purpose is to promulgate life, if that's what you think its purpose, that's not the universe we live in. Now, so I just wanted to give you a lecture in one facet of modern cosmology, because it takes me back to the way I want to end this to some extent. And that is, what I've shown you is that there's no evidence, or I've argued there's no evidence in biology for design. I've also argued in some sense, if we look back at the universe in cosmology, it's an amazing place, but it's not clear that the universe has been designed to be maximally hospitable either. Does that mean there is no purpose or design? Absolutely not. And scientists often abuse this notion. Physicists are, again, the worst here, the most obnoxious. Physics has been so successful that we have this tendency to say that if it isn't science, it doesn't matter. That science is everything. And if science can't say something about that issue, then it's not worth talking about. But that, of course, is completely wrong, and some people call that science versus scientism. Attacking a belief in purpose or design is acceptable, but it's a philosophical stance. It's not a scientific one. You can make the statement that, look, there's no evidence for design in the universe, and we are completely irrelevant. There's no evidence that the universe is designed in any way. That's fine. And then you can say that there was no design. And that's a perfectly reasonable conclusion, but it's a philosophical conclusion. The science itself can't say one way or another. It just says it is what it is. And in fact, as my old acquaintance Carl Sagan used to say, absence of evidence is not evidence for absence. So the fact that there is no evidence for design is not proof that there's not some vague purpose or design to the universe. Okay? So I think scientists have to realize the limits of science in that regard. At the same time, we can enrich faith, if you call it enriching faith, in the sense of Albert Einstein and the sense of Steve Weinberg. Science teaches us to oppose blind, unquestioning belief. That's clearly the path to nonsense. So those people whose faith is based on blind, unquestioning belief, scientists should argue that that's not the path to knowledge. We can inform faith by the results of science. I was at the Vatican a few years ago, and I put it this way. It was a meeting of a few scientists and a few Catholic theologians from the Vatican, and we were lecturing to each other about the future of the universe, and I put it to them that they had to listen to me, but I didn't have to listen to them. Namely, and I didn't mean it in a, well, I meant to be facetious, of course, but it's true. If you want to have a sensible theology, it has to be consistent with what we know to be true about the universe. But what we learn about the universe is independent of our theology. So, in that sense, it is a one-way street. But we can inform faith. For example, we should respect religious sensibilities except when those sensibilities are wrong. For example, the earth isn't 6,000 years old. Just not. It's not something we should respect. It's nonsense. It's garbage. You're a hypocrite if you believe that and you get in a car. Because the same laws of physics and chemistry that tell you how a car works tells you that the earth isn't 6,000 years old. The sun, by the way, didn't stand still in the sky way back when, on a day when someone blew a trumpet. Homosexuality is not an abomination. What do I mean by that? Well, abomination is against nature. Of course it's not an abomination because there's all sorts of homosexuality, not just in humans, but in lots of species. So you might not like it. You might decide for whatever reason it's wrong, but it's certainly not an abomination. And by the way, women are not subservient chattel. Another of the tenets of most modern American modern world religions. Really based on the notion that women are subservient chattel. They're not. And just so I can offend everyone, Native Americans as well as Judeo-Christians, the Kennewick man, who the Umatilla Native American tribe think was one of theirs, was not one of theirs, and we were stupid to respect their claims instead of studying this amazing 8,000-year-old skeleton. The respect of stupid Native American beliefs is not worth respecting when they're wrong. Okay? The Umatillians have a cosmology that tells us that the universe is 6,000 years old. This incredible 8,000-year-old skeleton, therefore, couldn't be that old and had to be one of theirs. And the fact that it happened to have Caucasian features, which certainly flies in the face of conventional wisdom about how humans came to North America, was fascinating. But for 3 years, it couldn't be studied because it had to be put under locks because of this pseudo-religious debate. And the Bible, Quran, and etc. are historical documents. That's what they are. They're written down by human beings. They were passed down by largely illiterate peasants through their oral tradition. And therefore, much of what is in the scriptures is just inconsistent with what we know about the world. That's just the way it is. Okay? Now, this whole lecture series is about science and religion, and I've talked about it, and I periodically talk about it in different contexts, but I want to point out that it's not a big deal. I wrote a piece, I write a column in New Scientist, so I wanted to quote from something I wrote there. Because scientists like me, when asked, will express views on issues relating to purpose and religion, especially to counter ill-conceived notions that might mislead the public. But in our work, this thing we do every day, we focus on the scientific questions, which are the interesting ones, the ones that can be addressed by tools that we will use to explore the universe. Whether any form of religion can be made obsolete by our progress, which is supposedly a big question, is just unimportant. It's a trivial. If the new knowledge about the universe cannot be worked into the philosophies, then they'll become obsolete. If the new knowledge about the universe can be reworked in the philosophies, they won't be obsolete. We don't have to spend a lot of time debating this issue. And I would argue that the participants have changed, but this so-called debate over relation between science and religion hasn't progressed, I would argue, significantly in 400 years. Today's arguments about intelligent design that I talked about are very little different from those of Thomas Aquinas and William Paley. The realm in which the debate is taking place, it'd be in microbiology or in cosmology, is very different. It's much smaller or larger. But the debate is itself the same. And focusing on these stale and uninteresting questions prevents the public from appreciating the really important questions, which is what we're learning about the universe. So my problem with this fascination with science and religion is it takes away from the fact that scientists, as my friend Steve Weinberg would say, most scientists don't think about God enough to be atheists. It just doesn't ever enter into it. Now, when it comes to this issue of science and separation of church and state, I think the key point is one from Eugenie Scott, who said, the First Amendment protects against the government establishment of religion, but that doesn't mean we'll protect against bad science. We have to do that. And the bottom line is, the bottom line is the universe is a remarkable place without all the junk. And whether the junk comes from some religious fundamentalism or some New Age mysticism or whatever you want. You don't need it. It's fascinating. And I happen to think it's not only fascinating, but it's not immoral. I think only when we're willing to accept the universe for what it is, without fear, will we be able to build a just society. Science is not a threat to a moral world. It's the basis of a moral world, I would argue. And all of those things I talked about should be a part of a moral world. But the bottom line is that this is what really is important about science, is that it works. And that's the only thing that's important about science. It works, and we need it. And in fact, I would argue that at a gut level, everyone understands that, even those who complain that science has to be changed. For example, George Bush said, we got to teach both sides of the debate, right? But when the avian flu became an issue, he and everyone in his administration said, we got to learn how fast it's mutating from birds to humans. Okay? Not one person in that administration said, it's been designed to kill us. Forget about it. Okay? Whenever there's a challenge, people realize that science is the key. But it's more than that. It's also, I think, the source of wisdom and wonder. And we talk about it. People say that science is, the problem with science is it doesn't produce the kind of awe and wonder of other spiritual aspects of the human existence. And I just think that's because we do a rotten job selling it. And there's lots of ways to see this. This is my last picture. Here's a source of awe and wonder. It's not a painting. This is a total eclipse of the sun as seen from the other side of Saturn from the Cassini satellite. So the sun is behind it, and it's illuminating the rings of Saturn. Fine, but what's really neat, which you can't see in this image because the resolution of the projector, but if you go to the NASA website, you can see it, is right there. There's a little pale blue dot between those rings, and that's the Earth. And you see the Earth as a little pale blue dot in the darkness behind Saturn, telling us the fragility and the amazing aspect of here we are on this